Hello everyone, welcome back to histology pro. It's been a while, but I'm excited to be back with a new video this year, and I know many of you have been patiently waiting for fresh content. Thank you for your continued support and dedication to learning. Please remember to subscribe to this YouTube channel so you don't miss any of our upcoming histology lectures. Let's get started. Simple cuboidal epithelium is made up of a single layer of cells that are approximately as tall as they are wide, giving them a cuboidal shape. Each cells contain a centrally placed round nucleus, which is a key identifying features during practical examinations. Compared to simple squamous epithelium, this TU is thicker, reflecting its functional specialization. Simple cuboidal epithelium is primarily adapted for secretion and absorption, which explains its presence in organs such as the kidney tubules, thyroid follicle, and duct of glands. When identifying this epithelium on slides, always look for round central nuclei, uniform cell height, and a single epithelial layer surrounding a lumen. Now, let's look at the general characteristics of simple cuboidal epithelium. These cells are approximately equal in height, width, and depth, which give them their cuboidal appearance. Each cells has a round centrally located nucleus. This is an important feature for microscopic identification. Next is that the cells rest on a basement membrane which separates the epithelium from the underlying connective tissue. When viewed in cross-section, the lumen often appears circular due to uniform shape of the cells. Next is that there is a minimal intercellular space, allowing the cells to function effectively. Like all epithelial tissues, simple cuboidal epithelium is avascular, meaning it lacks blood vessel, but it is richly innervated, providing sensory inputs. Okay, let's see. Let's see where the simple cuboidal epithelium is found. Simple cuboidal epithelium is commonly found lining the kidney tubules, especially the proximal and distant convoluted tubules, where it plays a key role in absorption and secretion. It is also present in thyroid follicles, forming the follicular epithelium, which is responsible for thyroid hormones secretion and storage. Additionally, simple cuboidal epithelium lines the small duct of exocrine glands, where it helps support secretory products. Another important location is the surface of the ovary, also known as the germinal epithelium, which covers the epithelium. This location highlights the roles of simple cuboidal epithelium in secretion, absorption, and transport. Now, this slide presents the photomicrograph of the renal tubules of the kidney. It shows this photomicrograph, as you can see here, shows the renal tubules of the kidney lined by simple cuboidal epithelium. As been said in the previous slide, talking about the characteristics of simple cuboidal epithelium, which says that it consists of a single layer of cube-shaped cells with centrally placed round nuclei surrounding a distinct lumen. The simple cuboidal epithelium in renal tubules is structurally adapted for absorption and for secretion. In the histological image provided in this slide, the proximal convoluted tubules can be identified by the following key features. Looking at the lumen of the proximal convoluted tubules, it appears small, narrow, and often irregular or partially closed. This is due to presence of dense brush border, also known as microvilli, on the apical surface. Looking at the nucleus of the proximal convoluted tubule, they are round, centrally placed, and appear closely together compared to the distant tubules. As I've said that the the cells of the proximal convoluted tubules often possess microvilli at the brush border. Especially, the purpose is to increase surface area for the absorption of water, ions, glucose, and other substances. Now, in the same histological image, we can see the distant convoluted tubule has been labeled. It can be identified by features that clearly distinguish them from the proximal tubules. The lumen of the distant convoluted tubules is wide, clear, and well defined, and often more open and circular than that of the proximal tubules of the kidney. Also, the nucleus of the distant convoluted tubules are round, centrally placed, but they appear more distinct and fewer per tubule due to thinner cytoplasm. So in this slide, you can successfully distinguish between the proximal convoluted tubule and the distal convoluted tubule in your kidney slides. Functionally, this epithelium plays a crucial role in urine formation, electrolyte balance, homeostasis. Damage to these cells can impair renal function, highlighting their clinical importance. In this histological slide, known as the ovary, we can simply identify the simple cuboidal epithelium. Simple means one layer. So, uh, each lumen is lined by one layer of epithelial cells. Then the cell shape is cuboidal. That means their height is approximately equal to their width. The nuclei is round, you can see, centrally placed, which is visible in the epithelial cells surrounding each lumen. So this shows how simple cuboidal epithelium looks like. Looking at the function of simple cuboidal epithelium, one of its primary functions is absorption, especially in the renal tubules of the kidney, where water, ions, or known as ions, and essential substances are reabsorbed. It is also specialized for secretion. A good example is the thyroid gland, where cuboidal epithelium cells secrete thyroid hormones. Simple cuboidal epithelium also plays a role in excretion, especially in the kidney, where metabolic waste products are eliminated. In addition, it provides limited protection, forming a barrier that lines ducts and tubules. Finally, it aids in transport of ions and fluids across the epithelial surfaces, which is essential for maintaining fluid and electrolyte balance. Now let's discuss the special modification of simple cuboidal epithelium. In certain locations, especially in kidney tubules, the apical surface shows microvilli. This increase the surface area and enhance absorption. In the basal surface of the cells, often shows basal enfoldings, which are adaptation for active transport of ions and fluids. The cells are connected by tight junctions, which help maintain structural integrity and prevent leakage between adjacent cells. Additionally, the cytoplasm is rich in mitochondria, providing the energy required for active transport processes. These special modifications allow simple cuboidal epithelium to effectively perform absorption and secretion. Clinical relevant conditions involving simple cuboidal epithelium includes renal tubular damage. Damage to the renal tubules leads to impaired reabsorption of water, electrolytes, and nutrients, resulting in abnormal urine formation. In polycystic kidney disease, abnormal proliferation of cuboidal epithelium cells causes cyst formation, which disrupts normal kidney architecture and function. In thyroid or disorder, which involve follicular cuboidal cells, this disorder also, which such as hypothyroidism and hyperthyroidism, uh, affects thyroid hormone secretion and release. Neoplastic transformation of the renal cuboidal epithelium can give rise to cell carcinoma, a common malignancy of the kidney. So these are few clinical colorates of simple cuboidal epithelium. You can go online and search more. We have come to the end of today's video on this channel. If you enjoyed it, don't forget to like, subscribe, hit the notification bell so you don't miss our future videos. Thanks for watching. My name remains Histology Pro. Bye for now.